everyone, welcome to Science Friday.
Here's some for E as well. The one on the top here is one of the ways that you can define E.
What makes a field more likely to have an unbalanced gender distribution?
So this can be like, in the case of this paper, gyrification or brain folds.
A neuroscientist started to look at the brain
as like the
more as an
interconnected,
incredibly negative consequences.
Good morning. Today I'll be presenting on MAOA, which is a gene, amygdala morphology, and antisocial personality disorder. First, I'll start with kind of why I'm presenting on this topic. So in 4th to 6th grade, I had a Chinese tutor, and every Friday we would walk to the public library. Sometimes we would stop at Walgreens and get a snack, or once we got to the library, we discussed homework or, just anything within the domain of Chinese, I guess. Over the years, I grew close with my tutor. He started to become less of a tutor and more like an older brother in that sense. In 6th grade, my parents sat me, my brother, and my sister down. And they said, Yushuan is dead. And that moment really kind of, it stung. It kind of hit me. Being a curious 6th grader, I asked, why or how did he get killed? And my parents said, the police think someone had shot him. So as a 6th grader, innocent, that was pretty much the last thing I had expected them to say. That moment was really a moment of it sparked a curiosity or this questioning of why would someone be so violent and be so driven to shoot someone who is a good person, or was a good person in my eyes. And so that's kind of what I'll be talking about today. I'll be talking about one potential reason why people do violent things. Before I get into the paper, I'd like to start with some definitions. Monoamine oxidase, which will be abbreviated as MAOA, is an enzyme that breaks down neurotransmitters like serotonin and dopamine. And these neurotransmitters are known to be associated with aggressive behavior. So there are 2 different polymorphisms of MAOA, one called MAOA-L and one called MAOA-H. The L stands for low or low expression, and then H stands for high expression. So all you need to know is basically the low expression is associated with more violent behavior, and the high expression is associated with less violent behavior. The second definition or term I'd like to define is antisocial personality disorder, which is defined as a mental health disorder characterized by disregard for other people. And so naturally, you could see how if one person cares less about other people, then they're more likely to be aggressive or violent against them. And then the last thing, or last term, morphological abnormalities, and this is specifically in the brain. It just means the brain being oddly shaped in certain parts. So I'll give the context of the paper. There are 3 relationships that were known before the study was done. The first one is up here. I guess, will this work? Okay. There's a relationship between antisocial personality disorder and violent behavior. So I was talking about this a bit before on the slide previous. If one person is less likely to care about other people, then they're more likely to cause harm to other people. The second relationship is this one, and it's a relationship between violent behavior and morphological abnormalities. So there have been studies showing that how people who commit violent acts are likely to have a differently shaped brain, a physically differently shaped brain than what the brain of someone who would not commit violent behaviors would look like. The last relationship is between MAOA low and morphological abnormalities. So in non-aggressive patients, they've seen that people with MAOA low tend to have differently shaped brains than those with the higher expression of MAOA. So with that in mind, the paper is testing for relationships between morphological abnormalities, antisocial personality disorder, and the MAOA polymorphisms. I think this paper specifically focuses on MAOA low and how that has an effect. So any questions so far? Okay. So I'll get into the sample demographics. They basically had a sample size of about 38, I believe, prison inmates. And the important part of the table is this first bar. So they split the sample into 4 different groups, those with antisocial personality disorder and those without. And then within those 2 groups, they split it into those with the MAOA high and MAOA low polymorphisms. So this was their categorization of their sample. And then the second part is kind of towards the bottom, where they scored, these are the averages of each group, but they basically did something called a PCLR test on all of these inmates, and the test is basically a test of how psychotic one is. It's out of 40, and the higher the score, the more psychotic. So this was used as a proxy for being aggressive or being violent. So that's just something to keep in mind. So again, the first piece of data. Here we see 4 brains. They're all the same brain, just at different angles. And when the researchers did an MRI scan of all the inmates that they were looking at, they saw two I guess, points of interest. The first is noted in blue, kind of this circle. And the second is noted in pink, the second circle from the left. And then on this side, this area is the same as this area, just from a different angle. And this area is the same as that, just from a different angle. So the areas marked in blue, they notice a decrease in surface area. And the areas marked in pink are where the researchers noticed an increase in surface area. To put it more graphically, within the group of people who have the MAOA low polymorphism, they found that those with antisocial personality disorder have a lower surface area in the blue area, or what is known as the blastrolateral nucleus, and a higher surface area for those with antisocial personality disorder in the anterior quartile amygdaloid. And I'll get into what these two do later, but this is just something to keep in mind. Looking at the blastrolateral surface area, so that was the blue regions, we can also graph it against the PCLR score, which, as you may remember, is a proxy for how violent one is. And we see that the higher the PCLR score, or the more violent, then the smaller the surface area of this certain part of the amygdala is. Yeah, I can speak louder. Who is having trouble? You? Okay. Can you hear me now? Okay. So then the last piece of data that I'll present on, which is quite interesting for a paper, is that they actually tested on like the robustness of their sample size. So here, these blue dots and this blue trend line represents a simulation of the needed standard, deviation in order to have a study that had in order to have a study that had a power of 80% and a p-value of less than 0.05. So what that basically means is that one is testing for or limiting false negatives and the other is limiting false positives. So this line is really like what you would consider like robust, robust data. So in their actual study, what they found is for their sample size, they have a much tighter standard deviation than what is needed for those 80% power and 0.05 p-value, which is good. It's showing that despite their smallish sample size, they have robust enough data. And this is for the study when they're looking at the decrease in surface area. On the right side, we see their data, or their analysis of their data for the increase in surface area. And again, well, not again, it falls on the line, but is a bit under the trend line. So I guess what these two graphs are showing is that for their sample size, their data is robust enough. Any questions? Yeah.
How is the sample size versus standard deviation line created?
Yeah. So Ian asked, how is the sample size versus standard deviation line is created? They use a simulation. I'm not entirely sure on the method, so I could read up and get back to you. But yeah, they basically simulated did some statistical analysis. I'm not 100% sure. Micah?
Yeah, I'm forgetting, was there an initial link that they knew between this sort of morphological difference and violence?
Yeah, so they initially knew that there's morphological differences between those with antisocial personality disorder a relationship between antisocial personality disorder and brain morphology, but they didn't know it within the context of MAOA. And this is what the study was testing for. Yeah. Any other questions? Wes?
Does it ever discuss, is the link correlated or is there a causation? And if so, in which direction?
Yeah, so this data is all correlative. Yeah. But the discussion, as most papers do, discusses potential implications, which I'll get into a bit later. All right. Any other questions? Cool. So just to wrap up the data, the researchers saw that those with MAOA and antisocial personality disorder have a decreased surface area in the BLA compared to those without antisocial personality disorder but are within that MAOA group. And then for the AOC, they see an increase in surface area instead. And then the last thing is that the sample size was sufficient for robust research. So getting into the implications, there was an decrease in surface area in the blasterolateral nucleus, which is intimately involved with the development of conditional fear. So the implication here is that those who are violent have a physical change in the brain where that is in charge of kind of dealing with fear. And so, that's kind of an interesting relationship to think about and, an area that needs more study, but looking at the link between fear and violence. On the other side, the anterior caudal amygdaloid, we saw an increase in surface area for those with antisocial personality disorder. And this one is a bit of a stranger connection. It's in charge of processing smell directly from the main olfactory bulb, which you might think has nothing to do with violence. But the link is a little bit stranger, in which a lot of mental diseases like Parkinson's are associated with decreased ability to smell, if not losing the complete sense of smell. So there's some area of research needed in terms of links between, I guess, mental diseases and also violent behavior. So I guess to kind of wrap up the presentation, I went into this topic and I guess looking into the papers with a curiosity as to why one would be violent towards another, and this is one potential reason. Thank you.